in the menu thing. I can check.
Yeah.
You found it? Yeah, great.
All right, I think we are ready to get started now. So welcome everyone to this week's PTC Nordic Talks webinar. And for today, I'm actually a little bit extra excited by having my colleague Carl Jansson here as our next speaker. So some of you might have already seen him. So if not, Carl is the AR and IoT evangelist in EMEA at PTC, and he will also talk about augmented reality use cases in the manufacturing industry today. But first of all, for those of you who are still new to the Nordic Talks webinar, my name is Torben Pilsson, and I'm the Partner Ecosystem Manager for PTC in the Nordics. And we are running these webinars every week, same time, where we invite customers and partners for some inspiration on any hot topics in digital transformation to see what is possible and how to make things happen. And all of our past webinars have also been recorded and are to be found on the registration site for this event. And the agenda for today is first a quick introduction by Carl about PTC and himself, and then he will touch base on a few challenges in the industry, how to address these, and then explain the business outcomes. And at the end, we will also have a Q&A session, so please keep your questions to the end. And of course, this webinar is also being recorded and available in just a few days. But now over to you, Carl.
Thank you, Tobbe. So quick introduction about PTC. PTC is a software company that is specialized in manufacturing software enterprises. Basically, it's a 30 years old software company that is based in Boston. We are started with CAD and PLM, and since recently we introduced SaaS, IoT, and augmented reality. So this is for the introduction, and I will get started with my presentation. Augmented reality use cases in the manufacturing industry. So my name is Carl Jansson. I'm an AR and IoT evangelist for PTC. I have about 10 years experience with AR. Let's go. So quick overview of the program. I'm going to have a look at or present AR in general, talking a little bit about software, hardware, but also where it can be applied in consumer environments. Moving on then to manufacturing, AR manufacturing environment for products and operations. I think, Tobbe, if you can mute, there's some people that I can hear. Moving on, so talking about a little bit of history about augmented reality. So the consumer AR started in 2012 when Google launched their AR glasses. It's a monocular eyewear where the data information is showing on the right eye in your field of view. Moving forward a bit, in 2016, Microsoft HoloLens launched the first version of their glasses. And this is a pretty advanced system that allows you to visualize 3D information through holograms. Those glasses are also aware of the environments. In 2017, RealWear launched also a monocular eyewear similar to Google glasses, but really focused for industrial applications. And then some other different companies have produced like Magic Leap AR glasses, or Unreal, Chinese brand that are tethered glasses. So you have a compute unit attached to it, which can be a bit limiting for manufacturing use cases. ARKit and AR Core for iPhone and Android, also important and shows that consumer AR, it's on the move. But it's mainly industrial companies who have started using augmented reality, realizing that this is a great tool for different reasons that I will explain in a bit. So the most widely adopted glasses, AR glasses in the industry are the HoloLens and the RealWear. Recently, both have specific specifications for industrial applications. A quick overview of the consumer AR. 2016, Pokemon Go had a big hit. They were basically, you're looking at Tobe, can you check to mute the participants, because I can hear some sounds? Thank you. So Pokemon Go, basically you're running around looking for those little animated 3D characters that are placed in the real environments. Then HoloLens came out with a few games, Robot Raid, shooting some aliens coming out of your wall, or Minecraft. But more interestingly, Snapchat, using AR filters to modify the look of your face, or adding content to your head, for example. IKEA and Nike launched some e-commerce apps where you can visualize the product you want to purchase before you buy it. You can put them in your environment. For example, IKEA, you are able to visualize furniture, the colors, the size, if they fit your room, and then decide if you want to purchase or not. Nike has the same kind of system where you're able to visualize shoes that are overlaid your real shoes, your actual shoes, so you can see how it matches your style, and then decide if you want to buy or not. And similar with L'Oreal, where you have apps similar to Snapchat that modify the color of your lips or your hair, or even your makeup style. So moving on to manufacturing environments, I will really talk mainly about, I think there are two companies that really stand out, PTC and Microsoft, for manufacturing AR. So Microsoft has a product called Vuforia, which is basically a developer's kit for computer vision, the most advanced AR computer vision available out there. And from that, it derives a lot of different products. Some of them belongs to PTC, and some have been custom-made AR apps that I will show later as well, using Vuforia engine. And then Microsoft have an application called Dynamics 365 that is specially tailor-made for the HoloLens 2, and allow to visualize 3D content, videos, and other stuff. That is also useful for manufacturing. And then there's a bunch of startups that are creating very specialized apps, and for example, Rootkitude, Scope AR, Reflect. But altogether, according to experts or consultant firms and market research analysis, PTC is way ahead in terms of augmented reality for industrial applications. And the reason is Vuforia, PTC has 30 years of experience with industrial manufacturing enterprises, and started with CAD, PLM, and IoT, as mentioned, and this information can be overlaid with AR technology. So it's a whole ecosystem related to digital thread that other companies don't have. If you want to create an AR application, you have a few choices, and you can start, if you want to do an AR application on a mobile phone, you will start with ARKit or ARCore for either iPhone or Android. But it's for developer, it's a developer environment, so it involves a lot of coding. If you want to be more VR and AR specific and do more fancy things, you will use a game engine called Unity that is the most adopted environment for 3D and AR, VR and AR environments. If you want to go even deeper and really want to use very advanced AR features, you will use Vuforia engine that is also a plugin for Unity. So those two platforms work together. And with engine, you will have to do a lot of coding, but you can do a very, very specific and tailor-made AR application. And I will show you some examples later. If you want to go an easier route, you can use Vuforia Studio. That is a technology based on the Vuforia engine. It's a platform where you can drag and drop content to create AR experiences in a very fast and simple way, and also very efficient for deploying on multiple devices. You can import CAD data and also IoT data to see in real-time information over AR overlaid information. There will be some examples of that later. About industrial applications, I have chosen to really present those two experiences that are, in my opinion, the most impactful in the industrial environment, which is working with the knowledge transfer or remote assistance. So for the knowledge transfer, there's this application called Refer Expert Capture made by PTC, where you're able to capture information from experts and then transfer it to new hirees or reallocated workers. Using an AR headset, you will be able to record the expert's knowledge when he wears it. He can do his everyday tasks, and the content he's showing will be recorded automatically, and I will show that later as well. For remote assistance, we have a Choke, also from PTC, that is a streaming application, streaming video, but with a subtle feature that you can do annotations on the smart pad, for example, and the annotation with the 3D with the AR technology will stick to the environment. So here, for example, if you show this this button here with a little drawing like this, and you move away the pad and come back to this location later, these markers will still be there. Talking now a little bit more about AR in manufacturing environments. So the important word here is the digital thread, and wherever there's a digital information, AR can be applied. So basically, AR can be applied in multiple departments. Starting with, as example, AR visualization for engineering. You are able, with AR glasses like HoloLens, to visualize 3D holographic CAD drawings. So it's very interesting for engineers to discuss among them the features and see where they can do the changes. They can see the real scale object, or even objects integrated in a real physical product. Now for corporate, AR is interesting because it brings a modern digital culture image, and it also allows savings on training, and I will show that or discuss that a bit later. AR for customer services, it improves using, for example, remote assistant Choke. It will improve customer satisfaction. It will, by creating a better service and quality, better service quality and uptime, and also potentially create a new revenue stream. In AR operation assistance, the end worker will get self-service options for training, and also it will increase technicians' efficiency and safety. AR for manufacturing, being able, for example, to see IoT information of machines or 3D procedural instructions, will increase the workers' opportunity, productivity, quality and safety, and reduce downtime of machines. AR for sales and marketing you will be able to demonstrate 3D products and showing their configuration, and also it will bring a brand and product differentiation, and also something I will show in a bit. So the adoption in industrial environments is mainly in service and manufacturing, but followed by marketing and product demonstration, training, and so on. So you can see here where the adoption has been starting and how it's evolving. Now, what are the current challenges of manufacturing companies? Basically, there are three different important sections. The most urgent and important is the worker skill gap. Basically, senior workers that are going to retire pretty soon, and leaving with them 30 years of experience. This is a challenge for companies and the young generation that is not maybe not interested to join manufacturing environments. But if you present AR headsets to the young recruits, I think they will be much more interested in joining. And with Refer Expert Capture, you will be able to capture the knowledge of the retiring workforce and transfer it to the young generation. That's where AR has a strong impact. For product and process complexity, we know that machines and procedures are getting more and more complex. And for this, the traditional way to training ways with classrooms and paperwork and so on is not the most efficient. Using AR, you'll be able to have much more information given to you, much more clear instructions, 3D information, holographic information, so you can walk around the models, understand or look inside and understand the system much better. And it helps for retention as well. Increasing customer demand, so production lines have to be changed because of features that are added or removed, and customization of objects and so on, of products and so on, will really make the challenge of updating the procedures of the or instruction sets of the machines. So with digital information, you will be able to update live new procedures and so on. So that's where AR is also very interesting, because you'll be able to get the latest information hands-free, look at the information, and then apply what you see in situation with the machines. So the value drivers of AR, mainly improving work efficiency, increased quality and yield, and reduced operation costs. And I will come back to those details later after presenting a few use cases. So use cases, I will talk firstly AR for products, but then AR for operations, mainly data visualization, see-through for products, and maintenance, assembly line procedures, remote assistance, and work instruction for the operation. Starting with customers for visualization. So customers find it more and more difficult to imagine how their design selection will look in the real world. So the consequences is that their indecision will delay sales and production. So here you can see an example of a customer looking at different colors of the boat he wants to order, or the different features, and you see how easy it is just clicking around, and you have a very clear understanding of what's going on. So the solution is really to build an application that allows the customers to customize and see the visualization of the variation of the product in real time. And here you see an app by Porsche that basically the customer is able to see the different colors, but also change the rims and see different configuration. And all this allows to shorten the sales cycle and improve the customer engagement. And here I will show you the IKEA app as well, where you can see how it works and how the furniture can be displayed in your environment. And once you're decided, you can purchase the furniture. All those applications are made with Referra engine. Now the product see-through, that is interesting for situation where it's challenging to demonstrate the new technologies that are inside the products. And the consequences is that it's challenging to explain and convince about the new features. Here, an example of see-through overlaid the real car. And here you can clearly see the technology in action. It's much simpler to explain how things work and why you should invest in this new technology. So the idea is to create an interactive AR application that demonstrates the internal features and functionality of your product. And here is an example of an engine. You can see the features or how the engine works, see-through, which is much better than a 2D printed document and so on. And here a very nice explosion effect that that engineers will be very interested to use as well, to discuss changes or design ideas and so on. So the outcome is a cost-effective way to view technologies at sales points or exhibition centers. And there's a few other companies that have done similar experiences, including Danfoss and Infinity. And here you can see the engine, how it should look inside the motorcycle. Talk about maintenance now. So the problem with maintenance is usually that there is an unstructured format of manufacturing processes, service instructions, and equipment maintenance. And the consequences is increase in delays and poor customer satisfaction. So here's an example of Caterpillar that made an app with, here you can see real-time IoT data augmented over the machine or inside the machine, but also a procedure on how to do the assembly for maintenance in real time and in situation. So it's very, very easy to understand and to learn. So the ideal is to create an AR app that is interactive and that is connected to 3D instructions, that shows 3D instructions, that is connected to CAD, PLM, or IoT. And here you see an example of a Volvo truck that is using existing CAD data to leverage AR instructions. So here you have some guidance where to put the smart pad, and then you see exactly which pieces to work on and what to do. So the outcome of this is a structured processes, service and maintenance instruction set, and leading to a better first-time fix rate. Now going to the assembly line, where AR can be useful here. So in assembly lines, sometimes you will have an efficient way to train the new hires, as I mentioned earlier, in assembly lines due to the increase of customer demand. And that will, the consequences will be production delays. So here's an example of with BAE Systems, where they have produced a step-by-step work instruction for the HoloLens leveraging existing CAD data. And the result is 30% reduction in training time, and for new hires, and 50% reduction time in assembly lines. And here you can see clearly the 3D holographic assembly work instruction. See how easy it is to understand and to get the right information at the right time. Okay, so this Vestas has a similar system, and all this has been done with V4 engine. Talking about remote assistance, Toyota is the biggest user of V4 Choke, and in pandemic times there's challenges with travel restrictions and lack of experts. So the consequences is production line are delayed due to repair and maintenance issues. So here, example of V4 Choke, and so the solution is really to use a remote assistant tool like Choke to enhance remote productivity and assistance, and this will improve overall operation efficiency and improve mean time to repair. So you see an expert talking with a technician in the field, and you can see clearly that the annotation sticks, so the phone can move, but the annotation, the circle stay, and that's extremely useful. Moving on to work instructions. So here earlier I told you that before expert capture is good to capture experts' knowledge and transfer it to the young generation, but it's also can also be used in certain cases where there is an urgent need to move a production line from production line know-how from one facility to another, and if that's not possible, there will be delays or incapacity to produce. And so the solution here is to use V4 expert capture to transfer expert knowledge rapidly and remotely. And here you can see the example of an expert recording what he's doing, his everyday procedures. So there's no need of shadowing. There's no need of the expert to take time off to write down instructions or to have a film crew, etc. to make the videos. It's recorded with HoloLens or AR glasses, edited remotely, and then played back on multiple devices. And here you can see the worker learning from what he sees and applying directly his new knowledge. So the outcome is really improved time to market and a quick generation of training content and assembly and maintenance instruction sets. So in summary, we see that AR has a wide range of applications. We've seen remote assistance, we've seen real-time IoT data, we've seen CAD visualization and expert capture knowledge transfer, and 3D holographic work instructions, and also real-time interactivity. So back to our value drivers, talking about the workforce efficiency. We've seen that it has improved the productivity, improved training, and gives a better insight to the workers. Quality and yield, we've seen that it reduces scrap and rework, it decreases downtime, and also globally it increases revenue. For the operation costs, AR reduces labor and training costs, safety, compliance, and maintenance costs as well, and optionally can add a revenue stream. So that's what I wanted to present. I'm open for questions, but also if you want to know more about augmented reality and AR use cases for manufacturing environments, feel free to reach out either through my email or mobile phone. You can also connect with me on LinkedIn. I usually post quite a lot of new AR or AR non-AR technology related information that can be very interesting.
Thanks a lot, Carl, for sharing all those exciting AR use cases. So over to you in the audience for any questions that you have. So please go ahead. Anyone who wants to go first?
I guess I could start. I have a question if this technology is used in any machine park here in the Nordics, if there are any concrete examples.
So machine park, what do you mean by that?
Or production facilities.
Oh, production facilities, yeah. Absolutely. So it's, here I have a few examples. So Danfoss, Atlas Copco, Volvo and Trelleborg are using AR as much as Vestas, and Sandvik in UK facilities. Does that answer your question?
Yeah.
Yeah, great.
Great question. Anyone else would like to go next?
I mean, my second question could be like, what are the latest innovations within this field? What are the recent most updates? And
so that's a good question. Yeah. So I would say that AR is still very new, and in some environments or traditional environments, people will think that AR is a bit of a toy, but actually not. We've seen some numbers, and we've been able, by applying this technology to various companies, that we have a lot of use cases actually worldwide, and we can see a very dramatic improvement in those various fields I mentioned. So I think training is one obvious way to utilize the existing CAD data, for example, or assembly visualization. It can very easily be transported to augmented reality, to glasses or smart pads. And also expert capture transfer has been used in various situations in the Nordics, where there have been urgency, especially with the pandemic, when you're looking for setting up a plant in a remote place. There have been cases where a plant in the Nordics had to be duplicated in India, for example, or some remote situation. And with the pandemic, you cannot send experts over, to guide the local people on setting up the facilities. So expert capture is a great tool for that, and it has been implemented in record times in the beginning of the pandemic because due to the travel restrictions. And remote assistance is also used quite often to help remote, again, with the remote, traveling restrictions, having an expert being able to discuss with a customer on the field on how to fix or maintain problems. It's a way to speed up the current situation.
Thank you, Carl.
Carl, one question.
Sure.
Yes.
One question on, for all these AR and digital work instructions, do we need to have a cloud system, or is it possible that we can utilize on-premise applications?
So it really depends what kind of application you want to develop. If you want to use the packages we offer, so VFR Expert Capture and Choke, that's cloud-based. But if you want to build your own tailor-made solution by using VFR Engine and Unity, then you can decide where your your content will be stored.
Okay. You showed one example about the digital work instruction where a female was assembling some part.
Yes.
So how much for maybe as one simple assembly, how much time does it actually take for such kind of application to build?
Yes. So this really depends, again, what tool you want to use. If you want to do a very tailor-made application using VFR Engine, that needs, a bit more work because you will need to have developers. You have to really decide on the use case and do, the whole preparation. So I would say for a pretty simple AR experience, you will have to, plan like a month's time. But if you want to do something much quicker, you will use VFR Studio, where within a few hours you can have some work instructions set up just by drag and dropping existing content. So it's really up to you how detailed of an experience you want to build.
Thanks a lot.
Thank you. Thank you, Carl.
You're welcome.
Friends, time is actually unfortunately running out. Time is going fast as always. So thanks everyone for joining this session, and a special thanks to you, of course, Carl. But stay tuned for the next Nordic Talks already next week, same time, same day, with Emmy Juslehto, who is the CEO and co-founder of Arilyn, for a session on AR is the must-have killer app for product presentations. So that's going to be very interesting, of course. So with that, I wish you a great weekend and stay safe, friends. Bye-bye.
Same. Bye-bye.
Thank you.
Okay.
Bye-bye.
Bye-bye.
Bye.